Alright, so in this lesson, we are going to look more at box and whisker plots, except this time we're going to do a lot less creating and a lot more analyzing of the information in a box and whisker plot. So your goal for today is I can analyze box and whisker plots. Alright, so let's go ahead and get started. So first off, we have this box and whisker plot. It's already been created for us. It has a number line. It goes in intervals of 100. We have A, B, C, D, and E. Which number corresponding to A, the number corresponding to A is which of the following? So here is A. Is it the median, the least data value, the first quartile, or the third quartile? Excuse me, the third quartile. So A is over here, and that should be answer B, the least data value, also known as the lower extreme. All right, let's look at the second question. All right, here we go. So, to find the range of the data, which of the following should you compute? Now, before you even look at the answer choices, what is the range? Well, it's the biggest number minus the little number, okay? So, it's going to be E minus A. And so, which answer choice matches up to that? You should pick B right here. Number for E minus number for A. Okay, now if it asked you for the interquartile range, that would be D minus B, but that's not what it asked you for. All right, so let's take a look at example number 2. And so again, it gives you a box and whisker plot, and I believe this might be the same one as the last example, but we have different questions. The first quartile is closest to which number? Well, first, where's the first quartile? Okay, that's going to be the lower quartile. So that's going to be B right here. And so what number does B represent? 400. And that's going to be answer choice C. All right, let's look at the next question. Oops. The interquartile range, we were just talking about that, can be found by calculating which of the following. So again, don't even look at the answer choices. Figure it out first. How do you find the interquartile range? Well, it's going to be the upper quartile minus the lower quartile. So D minus B, which is answer choice D right here. And if it asked you for the range, it would be E minus A. All right, example number 3. So here's a box and whisker plot. It's talking about high temperatures in April at the beach. And it wants to know a very simple question. What is the median daily high temperature? So first off, where's the median? Well, you should know that it is this bar right here. But the second thing you have to figure out is what number does that correspond to on the number line? Well, if this is 70 and this is 80, does it count by 1s, by 2s, by 3s, by 4s, etc.? And you should have figured out that it counts by 2s. And so you're going to go to 72 degrees, which is B. All right, next question, example number 4. So here we have a box and whisker plot again, and it's the high temperature for 50 different cities. And so I'm going to scroll down a little bit. Which statement is true about this set of data? And so these are a little tricky because we have to investigate every single one. So is it the first one that the lowest high temperature is 70 degrees? Well, go to your lower extreme. Is that 70 degrees? No, it's 40. So that's wrong. Half of the cities had a high temperature of 75 degrees or greater. Okay, we don't know. We're going to get back to that one. The mean of the high temperatures is approximately 75. Now, I'm going to tell you right now, when you see mean, it is impossible usually to figure out the mean of a box and whisker plot. Because a box and whisker plot has everything to do with medians. Remember, you find the median of the data, the median of the lower part of the data. And so anytime you see mean, it is usually wrong. More cities had a high temperature between 40 and 70 degrees than between 84 and 100 degrees. So, here's the thing. With a box and whisker plot and no data information, we don't know what the actual data numbers were in order to figure out the box and whisker plot. We just don't know. And so that is wrong. And answer choice B is correct. And I want to explain to you why it's correct. And I need to erase some of this in order to show you. I'm going to use my red pen here. Okay, so there's going to be a follow-up question about this, but this is important. What we're going to do is separate the box and whisker plot into, into 4 different parts. Okay, now I drew a line at the lower extreme, at the upper extreme, and then at the 2 quartiles. And the reason why I did this is because I need to show you percentages. From here to here, no matter how long or short the whisker is, it is 25% of the data. Okay, oops, and I forgot another line right here. Oh my, I am messing this up. You draw a line at the median also, I'm sorry. Okay, so from here to here is 25% of the data. From here to here, again, no matter how big, no matter how small, it is also 25% of the data. From here to here, no matter how big and how small, it is also 25% of the data. And from here to here, no matter how big or how small, it is 25% of the data. And so this question here, half the cities had a high temperature of 75 degrees or greater. Well, here is 75 degrees at the median. And so is that true? Well, 25% here, 25% here, that's 50%. That's half. That is correct. Okay, I'm going to show you another example of that later. All right, example number 5. The box and whisker plot below shows the heights in inches of the students in a 7th grade class. Okay, so here's the follow-up question to what I just showed you. What percentage of the heights of students is between 60 and 65 inches? Well, here's 60, here's 65. Okay, now I'm going to switch colors and remind you, from here to here is 25%. From here to here is 25%. From here to here is 25%. And from here to here is 25%. So what percentage is between 60 and 65? What's 25 plus 25? 50. That's your answer. It's not too bad, but it is part of analyzing box and whisker plots. Okay, how about this one? What is the interquartile range of the data? Well, remember, interquartile is from the upper quartile to the lower quartile. So we have 45 minus 30, which is 15. Example number 7. According to the box and whisker plot, what percent of students study less than 16 hours per week? Here is 16, and it wants to know the percent. Well, I'm going to remind you. Here to here is 25%. Here to here is 25%. Here to here is 25%. And here to here is 25%. What percent of students studied less than 16 hours? 25%. All right, example number 8. Which box and whisker plot represents a situation where 75% of the data is 200 or less? Okay, well, draw your marks. There's 25%, and there's 25%, 25%, and 25%. Where's 200? 200 is over here. 200 is only 25%. Let's look at the next one. From here to here is 25%. This is 25%, 25%, and 25%. Now we need 75%. Here's 200. Well, 25 plus 25 is 50. That one's wrong also. Let's look at this one. Here to here, 25%, 25%, 25%, and 25%. Here's 200. How much does it represent? 50%. Nope. Let's check the last one. Here to here, 25. Here to here, 25. Here to here, 25. Here to here, 25. Here's 200. How much does it represent? 25, 25, and 25 is 75. D is your answer. And that is it, ladies and gentlemen. We're going to do more practice with analyzing, but that is a crash course. Remember to ask me any questions you have.